Welcome to The Explainer. Today, we're going to dig into a really tough question. Why is managing the risks of AI so incredibly difficult? And to do that, we're going to look back at some of history's most powerful and kind of scary disasters. Let's dive in.
So, let's start with a moment that many people will never forget. A single moment frozen in time.
Picture it. Tens of millions of people are glued to their TVs. They're watching NASA. We're talking the best scientists and engineers on the planet get ready to launch the Space Shuttle Challenger. This wasn't some high-stakes mission against an enemy. This was a moment of pure national pride, something NASA absolutely did not want to get wrong.
And that's it. That's how long it took for the entire mission to end in just a horrifying catastrophe, a failure that played out on live television for the whole world to see. The tragedy really forces us to ask a tough question. If an organization like NASA, which is so careful, so well-intentioned, if they couldn't stop this from happening, what hope do we really have of controlling a technology as complex, as fast-moving, and frankly, as poorly understood as artificial intelligence? Well, the answer, or at least a really big piece of it, lies in this powerful idea that explains why complex systems are just so dangerously prone to failure. So a sociologist named Charles Perrow came up with this theory, and what he argued was, whenever you have a system where all the parts are super intricately linked, that's what he called tight coupling, and there are so many interactions that you just can't predict them all, that's the complexity, well then failures aren't just a possibility, they become a natural, almost predictable outcome of the system itself.
And the 3 Mile Island nuclear accident is a perfect example of this. It wasn't one giant, obvious mistake that caused the partial meltdown. No, it was this cascade of tiny, unforeseen events. A little maintenance tag just happened to be covering a crucial light. A valve was mistakenly closed. All these small things interacting in a way the designers had never, ever imagined. It just goes to show how tiny failures can snowball into a total catastrophe. So what happens when we add another really dangerous ingredient to this mix?
Well, this whole dynamic gets way more dangerous when you throw in the massive pressure of economic competition. Okay, back in the late 1960s, Ford was getting hammered by competition from international car makers. So they rushed the Pinto into production in just 25 months, which was unheard of at the time. But in that mad dash to get to market, they built in a deadly flaw. A gas tank that was way too close to the rear bumper, one that was prone to exploding in rear-end collisions. Inside the company, the logic was cold, but it was clear. Get the car out fast, beat the competition, and we'll deal with the consequences later. Of course, the human cost of that decision was just devastating. And what's wild is, decades later, a chillingly similar story happened in the aviation industry. Boeing was racing to compete with its rival, Airbus, so they rushed a new flight control system onto their 737 MAX planes. They did it without enough testing and without enough pilot training. The result? 2 fatal crashes in just a few months, and the tragic deaths of 346 people. This is the exact same competitive race we see playing out with AI right now. You have top executives saying out loud that it would be an absolutely fatal error in this moment to worry about things that can be fixed later. So the really crucial point here is, how does AI as a technology actually stack up against these other high-risk systems? And this question brings us right to the heart of the challenge we're facing today. And this, right here, just brilliantly illustrates the core problem. Look, we build rockets and nuclear reactors based on the established, well-understood laws of physics. We know how they work. But with a lot of these advanced AI systems, we don't fully understand why they work the way they do. We're in a global race to build and scale a technology whose inner workings are, for all intents and purposes, a black box. And this lack of deep, fundamental understanding, it introduces a final and maybe the most profound level of risk. The things we can't even begin to imagine. Think about it like this. Imagine you're a turkey. Every single day for 1,000 days, a human comes and feeds you, takes care of you. From your perspective, every single piece of data you've ever collected suggests that humans are wonderful, benevolent, caretakers. Their one and only goal seems to be your well-being. The turkey's predictive model of the world is flawless, right up until the day before Thanksgiving. And then suddenly, something happens that was completely outside of its frame of reference, making all its previous data totally and completely useless. And that is what we call a black swan event. These aren't just things that are unlikely to happen. They are events we didn't even know were on the table. In the world of risk, this is the huge difference between a universe with predictable dangers, like the roll of a die, and one with unpredictable, system-breaking catastrophes. See, the problem is many complex systems, from Wall Street to advanced AI, they just don't follow nice, predictable patterns. A world of thin tails like human height is pretty easy to plan for because extreme surprises are really rare. But AI? It probably operates in a long-tail world where the biggest, most civilization-altering risks are the ones we have never seen before and can't even properly predict.
So, after all this history and theory, what does it tell us about how we should be approaching the future of AI safety?
The ultimate takeaway is this: when you're dealing with systems that are incredibly complex, that are being pushed forward by these intense competitive races, and that are prone to catastrophic black swan events, our entire mindset has to flip. The burden of proof can't be on proving that something is dangerous. The burden of proof has to be on proving, beyond any shadow of a doubt, that it is safe.
And that, right there, is the defining technological and geopolitical question of our time. Thanks for joining this explainer.